Hello my dear students, I am Priya Patil, lecturer in Information Technology Department of Government Polytechnic Yavatmal. In this session, we are going to learn IPv6 Packet Format and its extension headers. After this session, you will be able to explain the significance of each and every field of IPv6 datagram format. All these are the outline. We will learn the IPv6 datagram fields, extension headers, type of extension headers and the formats of extension headers. First we will see the IPv6 datagram. In IPv6 datagram, it is composed of base header and payload. Base header is having the fixed size of 40 byte and this base header is followed by the payload. The payload is having the size of up to the 65,535 bytes. Again, the payload is composed of extension headers and data packet from upper layer. Extension headers are optional. It means that they may present or they may be absent. And these extension headers are followed by the data packet from upper layer. From upper layer means from transport layer. Here we can say that the transport layer because IPv6 protocol works at the network layer and in ISO OSI model, transport layer is present as the upper layer of the network layer. So we can say that data packet from transport layer. This is the basic structure containing each and every field of the datagram. Now we will see the working or the significance of the each and every field. First field is the version. It is having the size of 4 bit and this field is used to indicate the version number of internet protocol. So the name itself of the IPv6 indicate that the internet protocol version number 6. It means in IPv6 datagram, this field always contain the value 6. This field is followed by the next field, priority. Priority is again having the size of 4 bit and this field is used by the originating node means the source and again it is used by the intermediate router between the source and destination. This field is used by the source to define the priority of that datagram, priority of the packet. Depends on the priority of the packet, the intermediate router will take the decision whether to forward the packet with the highest priority or with the low priority. In case of the congestion, this field is very important and is used by the router. This field mainly contains the value between 0 to 7. In that case, 0 means the low priority and 7 means highest priority. Suppose if there is a datagram forwarded with the value 7 containing in a priority field. So 7 indicate that the highest priority. So when any intermediate router will receive that packet and notice that it contains the value 7, it means it is having the highest priority. And if there is a congestion in the network, then even though there is a congestion in the network, it will forward the packet with the highest priority. It will not discard the packet. But if it will receive the packet with a low priority, suppose the priority will contain the value 0, then in that case, if there is a congestion in the network, then the router may discard the packet. So this field is very important in case of the congestion and this field is set by the source and it is used by the router. Next field is a flow label. It is again having the size of 24 bit and this field is used by the host for requesting the spatial handling by the router within the network. It means that this field is again set by the host and it is used to indicate that the packets are forwarded in a particular sequence. Means this field is used to indicate the sequence or the flow of the packet. The router will use this field to transfer the packet or to forward the packet with a particular sequence. This field is mainly used in the real-time services because suppose that there is a broadcasting session, then in that case that packet is forwarded in a particular sequence and they will reach to the destination in that sequence only, so that the reordering of the packet will not is avoided at the destination place. Next field is the payload length. It means that length of payload. This field indicates the length of the payload. This field is included because the length of the payload is a variable size field. Its length may change because its length depends upon the presence or absence of the extension header. We have already discussed that the extension headers are optional. They may be present or they may be absent. So by payload, so that we can say that payload contains the extension headers and data packet from the upper layer. So by defining the length of the payload, we can combine the length of extension header and data packet from upper layer. Next field is the next header. Again, it is having the size of 8-bit and it defines the header which follows the base header. It means that this field defines the two things. In case if there is its values again depends upon the extension header. If extension header is absent, then in that case the base header is directly followed by the data packet from upper layer. So in that case, if the extension headers are absent, this field indicate the protocol which is used in a data packet. The second case is that if extension headers are present, then in that case the next header field is used to indicate the next header which follows this base header. It means it is used to indicate the extension header which follows the base header. Now we will see both cases. Now first we will consider the first case, that is if the extension headers are absent. So when the extension header is absent, then in that case next header field is used to indicate the protocol which is being used in the data field. Okay, so suppose we consider that the next header field contains the value 6. Again 6 is the value. It is used to indicate the transport layer protocol. It means that if the 6 is the value contained in the next header field of the base header, then we can say that this base header is followed by the data packet which contains the TCP, which uses the TCP protocol. Again, if the base header contains the value 17 is the value used for the UDP protocol. It means the user datagram protocol. It means that it is followed by the data from upper layer and this data uses the protocol UDP. Next one, if the TCP contains the value 58 it is the value that is used for the ICMP version number 6. So it is used to indicate that the base header is followed by the data from the upper layer and this data field use the protocol ICMP version number 6. Now we will consider the second case, if the extension headers are present. So in that case this next header field is used to indicate which extension header follows the base header. Suppose if the next header field contains the value 0, then in that case 0 is the code which is used for the hope by hope option header. It means hope by hope extension header. It means that the base header is followed by the hope by hope extension header. Again hope by hope extension header contains the next header field and this next header field contains the value 51. Then again the 51 is the value for the authentication extension header. So we can say that the hope by hope extension header is followed by the authentication extension header. Again the authentication extension header contains the field next header and next header contains the value 6, and we already learned that the 6 is the value for the transmission control protocol, which is used, that means the protocol which is used in a data from the upper layer. It means the data field. So we can say that the TCP is the protocol using the IPv6 data. So the next header field is used to indicate that it is used in the two cases. If the extension header is present, it will indicate the extension header which follows the base header, and the sequence of the extension header is a continue depending upon the value of the next header. And if there is no extension header, then in that case the next header field of the base header is used to indicate the protocol which is used in the data field. This is the same explanation again. This is the diagrammatic representation in which the first diagram shows the IPv6 datagram format, in which the next header field contains the value 6. 6 is used to indicate the TCP protocol. It means that we are using the TCP protocol in the payload in the data. In the second representation, 43 is the value used for the routing header, so that if the 43 is included in the next header field of the base header, then it indicates that the base header is followed by the routing header. Again, routing header contains the value 17 in the next header field, and this 17 indicates that it is followed by the UDP, that is the user datagram protocol. Again, the last one figure indicate the same thing. 43 is used to indicate the routing header. Routing header contains the value 60. 60 is used to indicate that it is followed by the destination option. Again, destination option contains the next header field containing the value 6. Again, the 6 is used to indicate that it is followed by TCP. Next field is a hop limit. It is having the size of 8-bit, and this field is used to stop a packet to loop in a network indefinitely. It means that it is used to define the life of that particular packet. It is works exactly like the time to loop field of the IPv4 header, and this field is very important because when each time when the datagram is forwarded by the router, when that particular datagram is received by the router, then in that case the router will decrement the hop limit value by the 1. When this value reaches to the 0, in that case that packet will be discarded. So it is helpful to avoid the infinite loop of that packet in the network, so that at a particular time when this hop limit becomes 0, at that time that packet will definitely get discarded. Next field is the source address and destination address. Again, both are having the size of 128-bit, and the source address, it means the address of the originator, that means address of the sender, the computer which want to send the data, the address of that particular sender. And the destination address, it means that the intended final recipient of that packet, or the final destination of the packet. Destination address, it means the intended recipient's address. And also the source address must be the unicast address. Obviously data is sent by only one sender, so we can say that it is a unicast, that is sent by a single sender. And the destination address can be the unicast. It means that it may be one sender, one receiver, one sender, many receivers. So we can say that it can be the unicast or multicast address. But in case of the IPv6, destination address is not a broadcast address. Broadcasting is not. I have also created this animation so that it will be better for you to understand the concept. In this diagram, the computer in a network A want to send the data to the receiver in a network B. The sender's address is below that computer receiver's address is written below that receiver's picture. So suppose if the sender want to send IPv6 datagram to the receiver, so in that case all these are the field containing the value. In that case the 6 is the value, first 6 indicated by the red color. It is used to indicate the version number 6. It means that it is the Internet Protocol version number 6 IPv6 datagram. And the priority and the flow level fields are keep blank because the priority and the flow level fields values depends upon the senders. If sender want to give the highest priority, low priority, this value will be changed, so that we will ignore these fields, and we focus on yellow color field, that is a hope limit field. It contains the value 64. As I have already told you that the hope limit field value is decremented by the router each time when it is received by that particular router. Now the router number 1 received the packet which is sent by the sender. Router will open the packet and will decrement the value by the 1 of the hope limit field. It means that the 64 becomes 63. Again forward it to the router number 2. It will again decrement this value so that it becomes 62. Again router number 3 decrement this value and it becomes 61. Now the receiver will receive the packet successfully. Now we will see what if that particular hope limit field becomes 0. Now we will consider the second representation, animation. Sender will again send the packet containing the hope limit field as a 2. Router number 1 receives the packet, decrement the value by 1, it becomes 1. Again the router number 2 decrement the value by the 1 and so it becomes the 0. At that time the router will receive the packet. Okay. Now we will see the IPv6 extension headers. All these are the types of IPv6 extension header: hope by hope option header, source routing header, fragmentation header, authentication header, encrypted security payload header, and destination option header. All these are the extension headers, and the value in the bracket it is used to indicate the value used for identification of that extension header. Now we will see each and every extension header one by one. All these are the formats of extension header. First one is a hope by hope option header. This extension header is examined and altered by each and every router in intermediate router between the source and destination. And if this header is present, it must always be the first header after the base header. If it follows the base header, then in that case base header containing the field next header field contains the value 0 because the hope by hope option header is identified by the value 0. This is the format of hope by hope option header. First field is the next header. It again used to indicate the type of the header which follows this header length, and next one is one or more options. The option field it contains the one or more options, and each option contains the 3 subfields, that is option type, option length, and option data. Second extension header is a source routing header. Source routing header, it allows the sender of the packet to partially or completely specify the route that the packet can take to the network. It means that in case of the source routing, it is the responsibility of the sender to set the route. But it can set the route in the 2 ways. It can use the strict source routing or the loose source routing. If it uses the strict source routing, then in that case the router has to specify each and every intermediate router or forwarding nodes between the source and destination. But if the source uses the loose source routing, it does not compulsory to specify or to list each and every intermediate nodes or the routers which forward that packet. Again, it is the header format. Next header field, again it is used to indicate the type of the header which follows this header. Then header extension length of the header. Then source routing type. Already we have discussed there are two types: strict source routing or the loose source routing. And this field is used to indicate that type of the routing. Segment left. This is source routing is very interesting, specifically for because of this field, because the segment left is used to indicate the routers that are till not visited by the packet. Okay, it means that they will be visited in a future by that packet. This is the diagram. This is the example of the source routing. Suppose A is the sender and B is the final destination. So in that case, there are three intermediate routers, that is router number 1, router number 2 and router number 3. When the source A send the data, in that case for sender A, the immediate destination is the R1. So so in the first box we can see that the source is A and immediate destination is R1. Okay, and the left is equal to 3. Left is equal to 3 means in future it means that after forwarding from this route it may reach to the R2, then R3, and then only it will reach to the final destination, that is a B. So we indicate that left is equal to 3 and this 3 means R2, R3 and B. Okay. Next one, when the packet will reaches to the R1, again R1 will forward that packet. It means from R1 the immediate destination is the R2. Okay, so that we can say that the source, again main source is A. Now the destination from R1, destination is R2, and the left, it means that they are not visited till to the R2 and B, and R1 is indicated in a black row because R1 is already visited by that packet. Okay, so that left is equal to 2 and this 2 means R3 and B. Again that packet is forwarded from the R2, so we can say that the source is the first source sender, which is A. Destination, it means the immediate destination from R2 is the R3, and the left is equal to 1. It means that after R3 it will left to visit is only the 1, and which is the B, and R1 and R2 are indicated by the black row. It means that they are already visited. Next one, at the last, when the packet again reaches to the R3, same concept. When it reaches to the R3, again the source, first source is A, now its immediate destination is B, left is equal to 0. After that it does not require to visit another intermediate router or any intermediate node, and left, so that left is equal to 0, and the R1, R2, R3 they are already visited, so they are indicated by the black color. Okay, and the destination is equal to B. It means that it is finally visited to the proper destination. This is all about the source routing. Now we will see the fragmentation header. The fragmentation is done. Fragmentation is a process. It is done by the host. It is not done by the router. Okay. The fragmentation means the main packet will be fragmented into the small parts and small fragments are created. This is the basic header format of the fragmentation header. The fragmentation header is used to specify how to perform the fragmentation and reassembly. obviously fragmentation means breaking the main packet into the small packets, that is a fragment, and reassembly, it means to collect all these fragmented packet and to reassemble them and to again create the main packet. All these are the fields. First one is the next header. Again, it is used to indicate the header which follows this fragmentation header. Reserve, it is reserved for the future. Fragment offset. The fragment offset is specifies the position in the overall message where the data in a fragment goes. It means that it is used to indicate that the position in the main message where the particular data from this packet will go. Okay, 00 again it is reserved. M is the flag. M flag, it is a 1 bit. It is a 1 bit. It is having the size of 1 bit. It may contain 0 or a value 1. 1 means more fragment. The more fragment, it means that after these fragments there are more fragments available, and so more fragments are available, and if it contains the value 0, it means that it is the last fragment and it is not followed by any other fragment. This field is very important for the important. It is used by the destination so that destination will get the idea that this is the last fragment, or it has to wait for the more fragments to come. Okay, if the M contains the 1, it means that it has to wait for the more fragments to accept them and to then reassemble them. But if it contains the value 0, it means that it is used to indicate that this is the last fragment and no need to require to wait for the more fragments. Identification. Identification is again having the size of 32 bit, and this value, this identification field contains a specific value, and this specific value is common for the each and every fragment of the particular packet. If there is a one main packet and of which we can create it 10 fragment. Okay, so in that case, in each of these 10 fragment, we enter the specific value. It means the sender enters the specific value because it is a process done. Fragmentation is a process done by the sender. So that sender will enter specific value. Suppose we can see that's a 40. 40 is the value it can be entered in each of these fragment. After that, when the receiver will receive the packet, it will check that identification field. It will collect all the fragment containing the 40 as a specific value in the fragments and in the identification field of the fragment, and after that it will reassemble them. This is the fragmentation process. So the unfragmented part, it means that the base header. Okay, and this base header is the unfragmented part. We don't have to fragment it, and only the payload part is fragmented. And so that this, after the fragmentation of this payload part, we can create the first fragment, second fragment, and third fragment. And between the base header and the fragment part, we can include the fragmentation header, whose field we already learned. This is the process we done at the center side. And now the reassembly process. This process is done at the receiver side, that is at the destination side. Again, what the destination will do after receiving all this packet, it will remove the fragment header and it will make a sequence of the fragmentable part, that is fragment 1, fragment 2, fragment 3. It can make a sequence of this payload field, and only the one unfragmented part, that is the base header, is attached to it. It will remove the fragment header of each and every fragment. Now the next header is authentication extension header. This header provides the authentication and data integrity. It provides the authentication for the source. It means that it is used in authenticating the origin of the data. It means the original source of the packet. Data integrity, it means that it is used to guarantee the integrity security of information that is being sent. It means that it is used to ensure that both the payload and the header, they have not been changed during the transmission. It means that it will identify if there is alteration of information while the transmission of the packet. This is the packet format of the authentication extension header. Base header is as it is, rest of payload is as it is, only the extension header is included between this both, that is a security parameter index and authentication data. Security parameter index is used to define the algorithm that can be used. It is again having the size of 32-bit and is used to define the algorithm which is used for the authentication. And the next field is authentication data. It is used to contain the value that is generated after application of that algorithm. Here we can see authentication algorithm is applied on IP datagram. After the application of authentication algorithm, new 128-bit authentication data is generated. So that the security parameter index used to define the algorithm, and authentication data is the data that is generated after the application of algorithm on the IP datagram. Next extension header is the encrypted security payload. This works similar like authentication extension header, and it is used to provide the data confidentiality by using the encryption, and it again provides the data authentication. It contains again the two fields, that is a security parameter index. Security parameter index again used to define the algorithm, and the encrypted data field contains the data that is generated after the encryption of the IP datagram by applying the algorithm. It contains the two modes. It is performed in two modes, that is a transport mode or the tunnel mode. In case of the transport mode, only the TCP or UDP payload is encrypted. It means only the data portion is encrypted in the transport mode, because the TCP and UDP is used in a data portion. Okay? In case of the tunnel mode, entire IP packet is encrypted. Entire IP packet, it means it includes the base header and payload both. Okay? Now we will see the diagrammatic representation. The transport mode is, in case of the transport mode, only the data portion is encrypted. Okay, so that after the application of algorithm, encrypted data and the index field is included. And in case of the tunnel mode encryption, both base header and the plain data both are encrypted, and after that the new packet is formed. New extension header is added. I have also created the quiz. You can solve this quiz by clicking on this link, and so that it will be easy for you to assess yourself. Just click on this link. This is the view. The quiz on unit number 2, topic name is IPv6 header format extension header. You can enter your roll number, name, mobile number, email address, all this information, and after that you have to solve this quiz. It is containing the 20 marks. Even after this session, if you are having any doubts, any question regarding this topic, then you can feel free to contact me by using my email